Hello viewers, through this video we will learn types of foundation or types of footings. If you like the video, please do share it and subscribe the channel. Foundation or substructure. The structure of the building is divided mainly into two categories. The part of the building which is below ground level is known as substructure. It consists of the foundation and plinth masonry which is constructed on the foundation and projecting marginally above the ground level. A foundation is that part of the structure which is in direct contact with the ground and transmits the load of the structure to the ground. The main purpose of the transmission of load can be satisfied by a particular type of foundation based on the properties of supporting soil. Functions of foundation: to transmit and distribute load of superstructure over larger area. To distribute the load on underlying soil evenly and thus to prevent differential settlement. To provide a leveled and hard surface for supporting the superstructure. To increase the stability of the structure as a whole against sliding, overturning, and other disturbing forces like wind, rain, etc. To prevent lateral escape of supporting material. Types of foundation: shallow foundation, D/B2. Isolated footing. Combined footing. Deep foundation, D/B2. Pile foundation. Under-reamed foundation. It shows the tree diagram for the foundations, or footings. Shallow foundation: if the depth of foundation is less than width of foundation, then it is known as shallow foundation. Shallow foundations are used if hard surface is available within reasonable depth below ground level. Isolated column footing: it is used to support individual columns. They can be simple or sloped and shape may be square, rectangular, circular. It is the most common footing used in R.C.C. construction. Combined footing: a combined footing supports two columns. It is used when two columns are so close to each other that their individual footing would overlap, so to avoid overlapping, a common footing is provided for supporting both columns is known as combined footing. It may be rectangular or trapezoidal in shape. Combined footing. Situation where combined footing is preferred: when the property line is so close to one column that an isolated spread footing would be eccentrically loaded when kept entirely within the property line. By combining it with that of interior column, the load is evenly distributed. Rectangular combined footing is used if sufficient space is available beyond each column and if load on both the column is same and distance between column is less. Trapezoidal combined footing is used when load on the column is different, so more footing area is required for supporting the column carrying heavy load and also if the distance between column is large. Cantilever or strap beam footing. It consists of two isolated spread footing connected by a rigid beam known as strap. The strap beam does not remain in contact with soil and thus does not transfer any pressure to the soil. The strap serves to transfer the column loads onto the soil with equal and uniform soil pressure under both footing. Situations where cantilever footing is preferred: when the distance between the two columns is so large that a combined footing becomes excessively long and narrow. When the column position is on the boundary of plot, it is not possible to provide footing for such column. When the distance of resultant of two column loads from the exterior face of the exterior column is less than 1/3 length of the footing. Cantilever footing. Mat or raft foundation. A mat or raft is a thick reinforced concrete slab which supports all the load-bearing walls or column loads of a structure and covers entire area of building. Situations where mat foundation is preferred: when bearing capacity of soil is low and loads are heavy, the use of spread footing would cover more than 2/3 of the building area and it may prove more economical to use mat foundation. If soil mass contains compressible lenses or if soil is sufficient erratic so that the differential settlement would be difficult to control. To reduce settlement above highly compressible soils by making the weight of structure and raft approximately equal to the weight of excavated soil. Raft or mat foundation. Raft or mat foundation. Deep foundation. When depth of foundation is greater than width of foundation, then foundation is known as deep foundation. DB. Types of deep foundation. End-bearing pile. These piles transfer load through soft soil to a suitable bearing stratum. Multi-storied buildings are invariably founded on end-bearing piles. End-bearing piles are useful when hard strata is available within reasonable depth in loose soil having low bearing capacity. Friction pile, the places where hard strata is not available at a greater depth, the piles are designated to transfer the load by the phenomenon of skin friction along the length of piles. Such piles are called friction piles. Friction piles are useful in cohesive soils with low bearing capacity. Pile foundations. Pile foundation systems. Foundations relying on driven piles often have groups of piles connected by a pile cap, a large concrete block into which the heads of the piles are embedded, to distribute loads which are larger than one pile can bear. Pile caps and isolated piles are typically connected with grade beams to tie the foundation elements together. Lighter structural elements bear on the grade beams while heavier elements bear directly on the pile cap. End-bearing pile. Friction pile. Thanks for watching the video. If you like it, do share it and subscribe the channel.